Good morning, student. M.Sc Physics first, semester second, paper second, atoms and molecule. Now we have to discuss in this paper number is PHCT 122, atoms and molecules. Now we have to discuss the four module in this paper. First one is atoms, second one is molecules, third one is spectroscopic techniques, and fourth one is Raman spectroscopy. Now we have to discuss one by one module. The first module is atoms. We are all of familiar of the atoms, how they produce or how they found the atoms. Now we have to discuss in this chapter or module first. First article is revision of atomic models. We already discussed these models in FIBSc. Now we have to discuss later in this M.Sc Physics first part, second semester, revision of atomic model. According to modern concept, the atom is composed of a nucleus which is surrounded by electrons. The nucleus is further composed of neutrons and protons. Neutrons means negative charge, protons means positive charge. The diameter of the nucleus is 10 raised to power minus 10 meter, averagely 10 raised to power minus 10 meter. The mass of proton is 1.673 into 10 raised to power minus 27 kilogram, and it possesses unit positive charge of 1.602 into 10 raised to power minus 19 coulomb. The neutron is heavier 1008 times than proton, but it does not possesses any electrical charge. That's why they are neutral. Both protons and neutrons are called as nucleus. But because they make the nucleus of atom. The electrons are revolve around the nucleus in shells or orbits at relatively greater distance from it. They maintain their distance. The electron possesses negative electric charge of minus 1.602 into 10 to the power minus 90 coulomb, same as positive charge. Only sign is change. Positive is charge is positive sign and negative charge is negative charge. The charge quantity is same, minus 1.602 into 10 to the power minus 19 coulomb is the negative electrical charge, and 1.602 into 10 to the power minus 19 coulombs is the positive charge, which is equal and opposite to the positive charge of proton. That's why they are in stable manner. The mass of electron is only 1 upon 1836 of the mass of proton. Now we have discussed the first model or primary model of the Thomson atomic model. Sir J. Thomson has discovered this model in 1898. Thomson proposed the model of an atom as a plum pudding model. Plum pudding means in Marathi एखाद्या प्लेटमध्ये जर आपण मनके ठेवले, मनुके ते जर जसे डिस्टन्स मध्ये आपण ठेवतो सेम त्या टाइप मध्ये हा मॉडेल आहे. That is called as plum pudding model. According to him, first one is an atom is a sphere filled with positively charged matter. The positive charge is distributed uniformly with sufficient electrons embedded in it to balance the positive charge as shown in figure 1. This is the figure. We have given the example of watermelon. All of you know the watermelon. Cut the watermelon and show the structure of the watermelon. These red colors are shows the positive charge, and these are the seeds. Black color seeds are the electrons distributed in following manner. Just like Thomson atomic model are composed of this model in this type. These are the green color are the negative charges, and these are the positive charges. These are the surrounding in the atom, same as the watermelon. Okay, and this is the Thomson atomic model. This is the diameter, or sorry, Radius of the uh, uh, radius of the sphere is 10 raised to power minus 10. Average 10 raised to power minus 10 meter. This is the model, diagrammatically model of the Thomson atomic model. Now, the radius of the sphere of an atom is about 10 raised to power minus 10 meter. We have already discussed this radius. An atom is electrically neutral. Why neutral? Because they are same positive as well as negative charge. That's why the electrical atoms is electrically neutral. So that the total positive charge on it equal to the total negative charge on it. Same charges are putting in this model. Positive, suppose 10 positive charges, equally 10 negative charges. That's why it is electrically neutral. Okay. Now the next one is the process. The electron possesses vibratory motion about their equilibrium position and causes emission of light. Electrons are vibration about their mean position. That's why it produces the thermal emission, and this emission is converted into the light. That is called as equilibrium position and cause emission of the light. Due to this assumptions or point of view in this model, some drawbacks are explained in this model. First one is the scattering of alpha particle incident on the metal foil did not explain how to scatter. This is the main drawback of this model. Then second one is the emission of spectral lines by the atom. This model of atom had therefore been discarded because of they does not give any information about the atoms, electrons and neutrons. That's why this uh, model has been discarded. Now, uh, about their model, the next model is Rutherford experiment of scattering of alpha particle. This is the second model. It gives the some ideas in first model, Thompson model, and they get the some assumptions in this model. So Rutherford performed experiment on scattering of alpha particles from a gold foil. Their thickness is 4 into 10 raised to power minus 6 meter thick, and obtain an important information regarding the structure of an atom. They give the golden foil. Why are giving the golden foil? Because in golden foil maximum atoms are released. That's why I use the golden foil. First one is alpha particle. Why are you using this alpha particle? Only alpha particle. First one is the alpha particle is a doubly charged helium atom that has lost both of its electrons. In other words, an alpha particle, the nucleus of a helium atom, that is helium atom minus it two electrons, it carries a positive charge equal to 2 electron there. Why to 2e? Because of it is doubly charged helium atom. That's why the electrons are 2e. Okay. Then second one, it is ejected from radioactive material like radium with high speed of 10 raised to power 5 meter per second and mostly carries high energy. That's why using the alpha particle. It can travel through few centimeter in air before being stopped. Their velocity is maximum. The next one is it can penetrate through few hundreds or tenth of millimeter of a solid before coming to the stopping. It causes fluorescence on striking against certain material. They can spotting against the material. This is the experimental setup of Rutherford experiment. Rutherford performed the experimental setup to study the scattering of alpha particle as shown in figure. This is the experiment of, this is the radioactive source, means radium put in this box one beam is incident on the golden foil and the electrons are scattered in this manner. This is the diagram. This is beam of alpha particle. This is the detector. These red colors are shown in detectors, and this is the golden foil, and these are the spotting of the atoms. ABC. We have noted the ABC. What is by ABC? Most of alpha particles travels through the uh, uh, traveling through the golden foil, and these are the some alpha particles are deflected by the golden foil. Is deflected particles, so these are the deflected. Then third one is C particle, some particles are get back to the golden foil. These are the weakly charged particle. That's why it is not penetrate the golden foil, and it is the back to the golden foil. Now there are some assumptions in this or the prediction in this experiment. First one is radium is used as a source of alpha particle. Why radium is used? Because they are the radioactive element. It is placed in a small box. The box is provided with a small opening. Second one is a very fine beam of alpha particles is emitted along the axis of hole, that is narrow opening. Third one is this beam is allowed to strike a thin golden foil about 10 to the power minus 6 meter thick. The golden foil scatters the beam of alpha particles in different directions, all possible directions. The alpha particles are received on fluorescent screen coated with zinc sulfide or some other fluorescent material. When an alpha particle strikes the screen, a flash of light is observed at the place where it strikes the screen. The next one is the flash can be easily seen in dark room by a microscope. It was observed that most of alpha particles pass straight through the golden foil, but some alpha particles suffered small deflection. A very small number of particles were deflected through large angle more than 90 degree. Because of their penetrating power is maximum, that's why it not scattered in all direction. They are traveling in straight direction. Very few are the scattered in 90 degree. Only rarely a particle reverse back along its own path, that is suffered a deflection through 180 degree, means back to the golden foil as shown in figure 2. The scattering of alpha particles is due to the force between the charged alpha particles and charge of atoms of the foil. Now next one, on the basis of alpha particles scattering through large angles, Rutherford proposed the following structure of an atom. These are the prediction of Rutherford's. First one is an atom contains a small central part called the nucleus, in which the whole mass and positive charge are concentrated. The whole size of nucleus is about 10 to the power minus 15 meter. In last model, Thompson model, the size of nucleus is 10 to the power minus 10 meter. Okay. In this model, they are the Rutherford are predicted the size of nucleus is about 10 to the power minus 15 meter. Means 10 to the power 10 is the size of the atom, and 10 to the power minus 15 is the size of the nucleus. That's why the total size is 10 to the power minus 15. The atom is electrically neutral. I have already discussed in this point. Neutral. Why neutral? Because of positive and negative charges are same. That's why it is electrically neutral. An equal number of electrons are distributed in the space around the nucleus to balance the positive charge of the nucleus. Now third one is electrons are not stationary. They are revolving around the nucleus in circular path in the same way as planet go around the sun. Now next, he assumed that the electrons are revolving at a high speed around the nucleus in closed circular orbit. The force of attraction between nucleus and electrons are balanced by the centrifugal force acting on the electrons. They are rotating about the centrifugal force, positive as well as negative force. Okay. Then some drawbacks are come in this model. First one is a revolving electron around the nucleus must be continuously accelerating due to the charge in the direction of motion at every point. Then second one is according to electromagnetic theory, an accelerating charged particles revolving electron must always radiate energy. Third one is the electron revolving around the nucleus possesses centripetal acceleration and there would be continuous loss in energy of the revolving atom, sorry, electron. The electron must move spiral path of decreasing radius and ultimately falls in the nucleus when its whole rotational energy is spent. The next one is according to electromagnetic theory, the revolving electron must emit continuous radiation of all increasing frequencies, but it is observed that elements emits spectral lines of fixed frequencies and not all of the frequencies. In Rutherford atomic model, there are no mention of distribution of electron. This is the big drawback of this atomic Rutherford atomic model. Now we have to discuss the next model is Bohr atomic model. In this model, the atoms are proposed by Rutherford assumes the atom consisting of a central nucleus and revolving electron is stable much like sun-planet system. However, there are some fundamental differences between in two situations. Rutherford says the electrons are revolving around the nucleus, but Rutherford says these are the stable electrons. This is the difference between these two models. And the second one is the planetary system is held by gravitational force while the nucleus electron system being charged object interact by Coulomb's law of force. The third one is according to classical electromagnetic theory, an accelerating charged particle emits radiation in the form of electromagnetic wave. The energy of an accelerating electron should therefore continuously decreases. The electrons would spiral inward and eventually fall into the nucleus. They emit all energy in the form of heat. That's why they fall into the nucleus. As the electron spiral inward, their angular velocity and hence their frequencies would change continuously, and so with the frequency of light emitted, thus they would emit a continuous spectrum in contradiction of the line spectrum actually observed. In 1885 to 1962, Neil Bohr made certain modification in these models, last two models, by adding the ideas of the newly developing quantum hypothesis. Bohr postulated that the electrons is allowed to occupy certain orbits of specific energies. Bohr proposed that electrons do not radiate energy as they orbit the nucleus but exist in state of constant energy which is called stationary orbit. This is shown in this figure. This is first orbit, second, third, fourth, and we have to give the name in K, L, M and M orbit. This means that the electron orbit at fixed distances from the nucleus. Bohr's work was primarily based on emission of hydrogen atom. This is the diagram of Niels Bohr atomic model. They are giving the name in all orbits. First, second, third. First is K, second one is L, third one is M, and last one is N. And this they using this number, they find the electron position in first electron using this formula 2 into n to the power 1. N means this number. This is the example of k is equal to n is k into k means first orbit, n is equal to 1. The equation using this equation 2 into n square, the number of electrons present in first model is 2, second one is 8, third one is 18, and fourth one is 32. This is the distribution of electrons. Now we have to complete this article. Thank you very much for being concentration.